This video involves rationalizing the denominator. Basically what it means is we can't have a square root in the denominator. So there's a couple of different types of problems for this. We're going to go through the 3 or 4 that we'll see. This first one here, we have a square root in the bottom of a fraction. We can't have a square root in the bottom of a fraction because that's an irrational number. Right now, square root of 14. So what I do to get rid of the square root of 14 is multiply square root of 14 times the square root of 14. So that would just be 14, but I have to do the top and the bottom here. And the confusing part for a lot of people, we've done this before where we had a monomial here. We just multiplied. It's a little different. This is actually a binomial, and it's the same principle we did earlier where we have to distribute the square root of 14 here and here. So the top of my fraction becomes 4 times the square root of 14 plus the square root of 14 times 2 is 28. So we leave that. And the bottom of the fraction is square root of 14 times square root of 14 is just 14. We picked that number so this would happen. Now there's no square roots in the denominator. We have rationalized the denominator, but we have to go one step further to simplify this square root here. This one is just 2 times 7. Nothing comes out of that from 14. So I have 4 square root of 14, square root of 14 plus 28. If I were to break it down, that would be 2 times 14. 2 times 7, so that's going to be 2 times 2 times 7 all over 14, and that becomes 4 square root of 14 plus 2 square root of 7 over 14, because in the square root these two, one crosses off and the other one comes out. So at this point I'm complete, but I still I have some idea about reducing this. It looks like it can be reduced. There's a couple of ways that this works. When you have a binomial involved, or trinomial, or more than one term actually, you can't just combine these two together and make that a 1 and a 7. It won't work that way because the 14 is attached to this. Now there's 2 methods for this. What I'm going to do is figure out a number that divides into all 3 of these numbers. And they're all even numbers, so I know I can divide all of them by 2. So what I'm going to do is divide each term by 2. Basically, it's multiplying by a half over half mathematically. So divide this by 2, that becomes a 2. Divide this by 2, that becomes a 1. Divide this by 2, that becomes a 7. I can't see that very well. The answer then would be, becomes a 1 and a 7. I'll fill it out better. And a 2. So the answer then would be 2 square root of 14 plus the square root of 7 all over 7. And that's the answer, but we're going to have to leave it at. Okay. Next problem is similar. We have a square root of 8 on the bottom. There's 2 options here. I'm going to show you both ways. First, what we can do is see the square root of 8. We can't have a square root on the bottom of a fraction, so I'll multiply the top and the bottom. That's 8. Square root of 8 over square root of 8. Remember, this is a full term, a binomial there. So I distribute the square root of 8 to each of these. So that's negative 1 times the square root of 8. I just put negative square root of 8. Minus the square root of 40. All over 8, which is good, but we have a lot of simplifying to do here now. Square root of 8, that would become then negative square root of 2 times 2 times 2, minus the square root of 40 is 2 times 2 times 2 times 5, all over 8. You can do the factor tree if you have to, but that's what it becomes. And then as I work with square roots, the 2 inside become 1 on the outside, and the other one cancels. So I have 2 square root of 2, negative 2 square root of 2. And again, this one here, 2 comes out as well. And 1 cancels. So I have minus 2 square root of 10 all over 8. And then I say, well, what number goes into all these? All these can be divided by 2. So I divide each of these by 2. That becomes 1. That becomes 1. And that becomes 4. So the answer is negative, I'll get another color in that one, negative square root of 2 minus the square root of 10 all over 4. And that's how we would leave our answer. We can't combine 2 and 10 because they're both under square roots. So that would be it. The other way that I was talking about doing it would be to start, instead of start going square root of 8 over square root of 8, I would simplify square root of 8 first. That's 2 times 2 times 2. So that becomes, the whole equation then would become negative 1 minus square root of 5 over 2 square root of 2. And now this 2 is fine on the bottom, the square root of 2 is not. So I would simplify by, or rationalize the denominator by saying square root of 2 over square root of 2. And that goes like that. Now the top of the fraction is square root of 2 times negative 1 is negative square root of 2. Square root of 2 times square root of 5 is square root of 10. And the bottom of the fraction is 2 times square root of 2 times square root of 2. But the square root of 2 times square root of 2 is just 2. So it becomes 2 times 2, or 4. Either way, I'm going to get the same answer. So both ways will work. Let's see what the next one looks like. Now we have something that we haven't seen before, and that's the bottom of the fraction has a binomial, which is a bigger problem because I can go through the same steps as before and it won't work the way I want it to. Because if I multiply the top and bottom by square root of 5 over square root of 5, what will happen is the top would be 3 square root of 5, and the bottom would be, I'd have to distribute the square root of 5, and I'd say negative 4 square root of 5 plus 5, because square root of 5 times square root of 5 is 5, and I still have a square root on the bottom. So this method is not sufficient for us. We don't want to do that. So I got to get rid of that. That's not the way to do this, and I have to figure out what can I multiply the top and bottom by so that the square root disappears. And what we do is we multiply by what we call the conjugate. And a conjugate basically is the same two terms with the middle operation reversed from plus to minus or minus to plus. And what happens is, so the bottom here would look like I would multiply by negative 4 minus the square root of 5. The first number stays the same. Second number is changed from positive to not minus. If it's already negative, we change it to positive. And then this goes negative 4 minus the square root of 5. Basically the same idea. We technically multiplied this whole fraction by 1 in the form of negative 4 minus the square root of 5 over negative 4 minus the square root of 5. The reason we do that is because watch what happens when I do multiply the 2 on the bottom, the FOIL. I'll say the first would be negative 4 times negative 4, that's positive 16. Then I'm going to say negative 4 times negative square root of 5. Negative times negative is positive, so I get plus 4 square root of 5. And I'm done with the negative 4. Now I say square root of 5 times negative 4, which is minus 4 square root of 5. And then the last would be square root of 5 times negative square root of 5, which is minus 5. Now, it's not magic. We selected this number here, this binomial, so that this would happen. And what happens now is when I combine like terms, these terms will cancel. 4 square root of 5 minus 4 square root of 5 will cancel each other out, and it becomes 16 minus 5, or 11. So the bottom of my fraction is just plain 11. Now the top of the fraction is just distribute the 3 into here and into here. So that's going to be 3 times negative 4 is negative 12. 3 times negative square root of 5, that would be minus 3 square root of 5. And at this point, there's nothing we can do to make that simpler. That's our final answer. You might notice if going back to your algebra days, if I said just multiply those together, you could, well, skip that. That's a different deal. Now this one here, with the same principle, we'd multiply by the conjugate. That's a word we have to know. Let's do this. That's a word that we're going to be asked to understand when they ask for the conjugate. Basically, the conjugate of 3 minus the square root of 5 is just going to be 3 plus the square root of 5. That goes on the bottom here, and on the top here, 3 plus the square root of 5. So that's what we're going to have for our things. And the top now becomes 9 plus 3 square root of 5. And the bottom, when I multiply 3 times 3, I get 9. 3, that's going to be plus 3 square root of 5. And this is going to be minus 3 square root of 5. And then the last term is going to be minus 5. Because square root of 5 times square root of 5 is 5. So these cancel, and I get 9 minus 5, which is 4. And that's the final answer for that one. Some of you eventually will start to realize that when we multiply conjugates together, the middle term will always cancel out. So some people don't even bother doing it, but I want to do that to show that that's really what happens. The next two are a little bit more complicated, but the same principle. We just have more work because the top is also a binomial. So if I think to myself, okay, what is my conjugate going to be? It's always for the bottom because I'm concerned about getting rid of the square root here. So that's going to be negative 2 plus the square root of 3. Remember, the first number doesn't change signs, just the second number. That's a 3. And that means I have to multiply that by the top by negative 2 plus the square root of 3. Now, the bottom isn't too hard to do. We can look at that. That's going to be negative 2 times negative 2 is positive 4. And then it's going to be minus 2 square root of 3. And then negative times negative is plus 2 square root of 3. And then square root of 3 times square root of 3 is 3, so that's going to be minus 3. So that equals, these cancel, and I get 4 minus 3 is 1. So the bottom of my fraction is just 1. The top is where it gets a little tricky, because I have to do FOIL here as well. So the first terms, that's negative 3 and negative 2. Negative 3 times negative 2 is positive 6. And I say negative 3 times the square root of 3 is minus 3 square root of 3. And then I'll say I'm done with the negative 3. Now I got negative 2. I'll do that in red. Negative 2 times the square root of 2 is minus 2 square root of 2. And negative 2 times square root of, square root of 2 times square root of 3 plus the square root of 6. So this looks kind of complicated. I'll write it all in the same color down here. 6 minus 3 square root of 3 minus 2 square root of 2 plus the square root of 6 over 1, or just as this. Now, when I look at this, say, what can I combine together? And I think of 2 and 3 make 6, but that doesn't work because there's 4 terms, and all of them have different square roots. Square root of 6 is not the same as the square root of 2 or square root of 3, so they're all different. So this is our final answer right here. All right, the last one. For this one, the number that we would use would be, the binomial would be negative 5 plus the square root of 3. Again, remember the first one doesn't change, second one does. And that's negative 5 plus the square root of 3. All right, the bottom would be negative 5 times negative 5, that's 25. Negative 5 times square root of 3 is minus 5 square root of 3. Negative square root of 3 times negative 5, negative times the negative is positive, so it's plus 5 square root of 3. And then square root of 3 times square root of 3 is 3, and it's negative times a positive, so it's minus 3. So the bottom of my fraction, these two will cancel, and I'll get 25 minus 3, which is 22. At the top of my fraction now will be, I'll do FOIL up here again, 5 times negative 5, that's negative 25. And I'll say 5 times the square root of 3, so that's going to be plus 5 square root of 3, that's good. And then I have square root of 3 times negative square root of 3 times negative 5 is negative times negative is also plus. So plus 5 square root of 3. And the last one is square root of 3 times square root of 3 with the negative. So that's going to be minus 3. So when I simplify the top now, nothing cancels, but I can combine some things together. Negative 25 minus 3 is negative 28. So I have negative 28. And then I have, this is all on top of the fraction. And then I have 5 square root of 3 plus 5 square root of 3 is plus 10 square root of 3. And the bottom is 22. And we feel like we're done. We have it in the best form. The only difference is I'm noticing something. That can I reduce this at all? And I look at this, and they're all three of these numbers have even numbers, or even numbers. 28, 10, and 22 can all be divided by 2. Now remember, I can't just do these two by themselves. In order to reduce these fractions, you have to reduce each term. So basically, if I divide this by 2, 2 is the only number that goes into all these. So this would become negative 14. This would become 5. And this would become 11. So the answer would be negative 14 plus 5 square root of 3 over 11. And that would be my final answer. Now, some of you should be thinking of, is there a reason that has to be for all three? Technically, what happens, I'm going to go through the idea of what really happens is mathematically, because I was doing that without stating why those rules are what they are. Technically, what we're doing, in order to reduce this fraction, we have to factor out a common factor. So I'm going to factor out a 2. So it's 2 times parentheses. Factor out 2 from here. So 2 times parentheses negative 14 plus 5 square root of 3. And the bottom 22, I'm going to factor that out to be 2 times 11. And then what I can do is cancel the 2 and the 2, and I'm left with negative 14 plus 5. So what I'm left with is the final answer. So this is the mathematical method, factor out of 2. A lot of times we speed it up by just doing it for all of them. Technically, we should do this every time, or at least no. Okay.